Let's take a look at radical equations and their applications. Specifically, we'll just be looking at radical equations. Now, as you might expect, a radical equation is one that has a equals in it for the equation part and has some kind of radical. Now, to solve a radical equation is what we're going to be taking a look at. Our first step is to get a radical by itself. And I'm going to put inside of parentheses here, do not create a fraction. These are challenging enough. You don't want to throw fractions into them. Step 2, raise both sides to a power equal to the index. So raise both sides to a power equal to the index. Step 3, if you have more radicals, so if more radicals, go back to step 1. So you start over. Step 4 is solve for x. Now that's pretty vague, solve for x, but at this point this could be a linear equation, could be a quadratic equation. Actually, depending upon what else is in the problem, you could have even something beyond that. So it has to be vague. And then step 5, check your answers. What you'll find is that these steps will give you the correct answer, but sometimes will give you false answers also. So you have to check your answers. Let's take a look at our first problem. Square root of x minus 2 is equal to 4. Now step 1 is to get a radical by itself. Well, we got the square root here. It's by itself. There's no numbers in front of it, no numbers after it, so it's just a square root. Step 2, raise both sides to a power equal to the index. Remember, the index is the number that's in this little slot right here, and if there isn't one here, as in this case, then it's by default 2. So we're going to square both sides. Now when your index matches the power you're raising it to, they're going to cancel each other out, and the radical will disappear also, and you'll be left with what's underneath. So this side just becomes x minus 2. 4 squared, 4 times 4 gives us 16. You know, take negative 2, move it to the right side, becomes a positive 2. And we get x is equal to 18. Maybe. Because remember, our last step is to check our answers. 18 minus 2 is 16. Square root of 16 does give you 4. So that checks. Let's take a look at another one. We've got the cube root of 9x minus 1 equals 2. Step 1, get a radical by itself. Well, with the radicals by itself, there's no numbers in front of it, no numbers after it. We just have the cube root over here. Step 2, raise both sides to a power equal to the index. Well, the number in this little slot, our index, is 3, so we're going to take both sides to the third power. And again, when your index matches the power you're raising it to, all that cancels away. It just leaves you what's underneath the radical. 2 to the third is 8. Now we're at step 3. If more radicals, go back to step number 1. We don't have to go back. There's no more radicals. Solve for x. So I'll take negative 1 over. This is a linear equation. It becomes a positive 1. 8 plus 1 gives us 9. And then we're going to divide both sides by the number in front of our x, which is 9. And we get x is equal to 1. Maybe. Remember, we have to check our answers. 9 times 1 is 9, minus 1 is 8. Cube root of 8 does give you 2. So it checks. Okay, let's look at our next problem. we have 3 square root of x is equal to 2x. Step 1, get a radical by itself. Well, the radical is not quite by itself. We have a 3 in front of the square root. But if I divide both sides by 3, I'd create a fraction. And we don't want to create a fraction. So let's go ahead and go on to step 2. Step 2 says raise both sides to a power equal to your index. Well, this is a square root, so we're going to square both sides. So we've got 3 square root of x to the second power is equal to x to the second power. Now, when everything inside of your parentheses is either multiplication or division, and you're raising it to a power, you can take everything to that power. So I'm going to take the 3 to the second power, and I'll take the square root of x to the second power. So I've got 3 to the second power, square root of x to the second power. And 2x times 2x just gives us 4x squared. Now 3 squared is 9. And here the square root of x to the second power, again, our index matches a power, so they're going to cancel each other away, so that just leaves us x. Equals 4x squared. Step 3, if you have more radicals, go back to step number 1. We don't have any more. Step 4, solve for x. Here we have an x squared, a quadratic. When you have a second power or greater, you want to get 0 on one side and then see if you can factor. So I'll bring 9x over. So we get 0 is equal to 4x squared minus 9x. And now we want to factor. Well, this is GCF. They both have an x in common. So I'll factor out an x, and that leaves us 4x minus 9. Now the zero factor property says if you get 0 on one side and you factor to the other side, you can set each factor equal to 0. So I'm going to set x equal to 0, and I'll set 4x minus 9 equal to 0. Now this is already solved, but this one will take the negative 9 over, becomes a positive 9. Then divide both sides by 4. And we got x is equal to 9/4. Now if we check this, if I put 0 in for x, 3 times square root of 0, square root of 0 is 0, times 3 is 0. Put 0 over here, 2 times 0 is 0, so that one checks. If I put 9/4 in there, square root of 9/4 is 3/2, times 3 is 9/2. If I put 9/4 over here, I get 9/2, so it checks also. I'm not sure if I have another room there. Let me start a new page. Okay, number 4. We have the square root of negative 6 plus 11x minus 2 equals x. Our first step, get a radical by itself. Well, this radical is not quite by itself. We got a negative 2 there. I'm going to take a negative 2 and move it to the right side. So we've got square root of negative 6 plus 11x is equal to x plus 2. Now step 2 says to raise both sides to a power equal to the index. Well, the index is numbered in a slot here. There is no number, so it's by default 2, square root. So we'll square both sides. So we've got square root of negative 6 plus 11x to the second power is equal to x plus 2 to the second power. Now over on the left side, again, when your index matches a power, they're going to cancel each other away. So that leaves us negative 6 plus 11x. And on the right side, x plus 2 to the second power means x plus 2 times x plus 2. You have to write it out this way. You can't just square the x and square the 2 because of the plus in there. Well, x times x is x squared. X times 2 is 2x. 2 times x is 2x. And 2 times 2 is 4. No matter where you are in algebra, in math, combine together like terms. 2x plus 2x is 4x plus 4. We're at step 3. If you have more radicals, go back to step number 1. We don't have any more. So go to step 4. Solve for x. Well, here we have a quadratic. We have an x squared. So you have to get 0 on one side. So I'm going to take the negative 6 plus 11x and move them over to the right side. So I get 0 is equal to x squared plus 4x minus 11x plus 4 plus 6. Remember, when you move anything across your equals, the sign changes. Combine together like terms. 4x minus 11x is negative 7x. 4 plus 6 is 10. Now we need to factor the right side. We factor it using the PSD method. Factors as x minus 2 times x minus 5. Zero factor property says you get 0 on one side, you factor the other side, you can set each factor equal to 0. So I'll set x minus 2 equal to 0, and I'll set x minus 5 equal to 0. And we end up with x equals 2 and x equals 5, maybe. Now if I plug these back in, let me try 2 first. Put 2 in here, I get 11 times 2 is 22. 22 minus 16 is 16. Square root of 16 is 4. 4 minus 2 is 2. 2 equals 2, so that checks. I go back to bed if I can't do basic math. 11 times 5 is 55. Minus 6 is 49. Square root of 49 is 7. 7 minus 2 is 5. And if I put 5 over here, I get 5 equals 5. So it checks also. So those are our 2 answers. Let's take a look at our next example. We have the cube root of 8x minus 1 equals the cube root of 3x plus 5. Now remember what our step said. Our step said to get a radical by itself. Here we have 2 radicals, and so we choose either one, and actually both radicals are by themselves. There's no numbers in front of it, no numbers after them. But that's not what the step says. Step says just get a radical by itself. So this is fine. This is by itself. Step 2, raise both sides to a power equal to the index. Index is numbered in a slot here, which is a 3, so we're going to take both sides to the 3rd power. Now remember, when your index matches the power you're raising it to, they cancel away, including the radical, and we're left with what's inside the radical. So we got 8x minus 1 equals 3x plus 5. Now we want to solve this. So I'm going to take the 3x, move it to the left side. I'll take a negative 1, move it to the right side. Anytime you take anything across your equals, your sign changes. So I got 8x minus 3x is equal to 5 plus 1. 8x minus 3x is 5x. 5 plus 1 is 6. So I get x is equal to 6/5. Now this one I'm going to go ahead and write out because I probably can't see it. I need to check it. So if I plug that in for x, I'm going to have 8 times 6/5 minus 1. And I'm wondering, this is a question mark, I'm wondering if that's equal to, plug in 6/5 for the x over here. Well, that gives me 48/5 minus 1 is 5 over 5. And this one, 3 times 6 is 18, so I got 18 over 5 plus 25 over 5. Well, 48 minus 5 is 43 over 5. And 18 plus 25 is 43 over 5. So it checks. So this is our answer. Let me start a new page. And let's take a look at our next example. We got square root of 2x plus 7 is equal to 2 plus square root of x. Now let's go through our steps. First step is to get a radical by itself. Well, the radical on the left side is by itself. There's no numbers in front of it. There's no numbers after it. So that's fine. Step 2, raise both sides to a power equal to your index. Let me put 2 here for step 2. So we're going to square both sides again. Now over on the left side, our index matches the power we're raising it to, so they cancel away. So that gives us 2x plus 7. Over on the right side, 2 plus square root of x to the second power means 2 plus square root of x times 2 plus square root of x. I can't just square the 2 and square the square root of x because the plus in here. Everything has to be multiplication or division for you just to be able to square everything inside. 2 times 2 is 4. 2 times square root of x is 2 square root of x. Square root of x times 2 is 2 square root of x. And square root of x times square root of x gives us x. Always combine together items that are alike. Let me put the x first, then the 4. And then we got 2 square root of x plus 2 square root of x. Since both of these are square root of x, I'll add the numbers that are in front of them. 2 plus 2 gives me 4 square root of x. Well, I'm down to step 3. Step 3 says if you have more radicals, which I do, go back to step number 1. So we're going to start over. Step number 1, get a radical by itself. Well, this radical is not by itself, so I'm going to work on that. I'm going to take this x plus 4 and move them both over to the left side. So I got 2x minus x plus 7 minus 4 equals 4 square root of x. 2x minus x is x. 7 minus 4 is 3 equals 4 square root of x. Now the radical is not quite by itself, but if I divide both sides by 4, I'm going to create a fraction. Remember, we don't want to create a fraction. That just makes our problems harder than they need to be. So I'm going to go to our next step. Step 2 says raise both sides to a power equal to your index. Well, this is a square root, so there's no number in the little slot here, so it's by default 2, so I'll square both sides. So I got x plus 3 squared, and I got 4 square root of x squared. Now x plus 3 squared means x plus 3 times x plus 3. And over on the right side, remember, if everything inside your parentheses is multiplication and division, and you're raising it to a power, you're going to raise everything to a power. So I'll take the 4 to the second power and the square root of x to the second power. So I'm going to have 4 squared and square root of x squared. I couldn't do that on the left side because that plus. Everything has to be multiplication or division. Well, x times x is x squared. X times 3 is 3x. 3 times x is 3x. And 3 times 3 gives us 9. Over on the right side, 4 squared is 16. And square root of x to the second power, again, your index matches your power, then they're going to cancel each other away along with the radical and leave you just what's underneath the radical. So we're left with an x. Always combine together like terms. 3x plus 3x is 6x plus 9 equals 16x. Well, step 3. If more radicals, go back to step number 2, or step number 1, sorry. Now, you shouldn't be going back to step number 1 more than once. If you're a second or third time going back, you're doing something really wrong. Step 3. Step 4. Solve for x. Well, this has a quadratic, so we want to get everything over on one side, 0 on the other, and see if we can factor it. So I'll take 16x over to the left side. And I get x squared plus 6x minus 16x minus 9 plus 9, boy, equals 0. Too many days off, I think. Combine together like terms. 6x minus 16x is negative 10x plus 9 equals 0. Now the left side will factor using the PST, and it factors as x minus 1 times x minus 9 equals 0. 0 factor property. If you get 0 on one side, you factor the other side, set each factor equal to 0. So I'm going to set x minus 1 equal to 0, and I'll set x minus 9 equal to 0. And solve that, and that gives us x equals 1 and x equals 9, maybe. Let's check that. If I put 1 up here, 2 times 1 is 2, plus 7 is 9, square root of 9 is 3, so this side's 3. If I put 1 over here for the x, I get square root of 1, which is 1, 2 plus 1 is 3, so I get 3 equals 3. So that checks. Now 9. 2 times 9 is 18, plus 7 is 25, square root of 25 is 5, so this side's 5. If I put 9 over here, square root of 9 is 3, 2 plus 3 is 5, so that checks also. Do I got room? I probably do, but let me start a new page just to be on the safe side. Some of these problems get kind of long, especially when you got two radicals like this, and you got different numbers in front of your x's. Minus square root of 4x plus 5 equals negative 1. Okay. Now, first step, get a radical by itself. Now it doesn't matter which one we get by itself, you just need to get one of them by itself. So I'm going to take this negative square root to the right side. So I'm going to have square root of 5x minus 1 is equal to negative 1 plus square root of 4x plus 5. Now notice when I move the square root across the equals, the sign in front changes, but nothing changes underneath inside the radical. So that was step 1. We got a radical by itself. Well, step 2, raise both sides to a power equal to your index. Well, these are square roots, so we're going to square both sides again. Now over on the left side, the index matches the power we're raising it to, so they cancel each other away. So I'm left with 5x minus 1 equals, and then on the right side, I'm going to rewrite that as negative 1 plus square root of 4x plus 5 times negative 1 plus square root of 4x plus 5. I can't just square the negative 1, square the square root, because the plus in there. Everything has to be multiplication inside your parentheses for you to take everything to the second power. Well, now I'll FOIL this, multiply everything together. Negative 1 times negative 1 is 1. Negative 1 times square root of 4x plus 5 is negative square root of 4x plus 5. Square root of 4x plus 5 times negative 1 is negative square root of 4x plus 5. And square root of 4x plus 5 times square root of 4x plus 5 gives me 4x plus 5. Well, combine together like items. The 4x I'll just put out in front here. I got 1 plus 5 gives me 6. And we got these square roots the same, so we'll add or subtract the numbers that are out in front. In this case, we got negative 1, which gives us negative 2 square root of 4x plus 5. Well, that was step 2. Step 3, if more radicals, go back, start over. Go back to step number 1. Well, we do have more radicals, so go back to step number 1. Step number 1 says get a radical by itself. So I'm going to take this 4x plus 6 and move it to the left side. So I get 5x minus 4x minus 1 minus 6 equals negative 2 square root of 4x plus 5. 5x minus 4x is 1x or x. Negative 1, negative 6 is negative 7 equals negative 2 square root of 4x plus 5. Now the radical is not by itself, but if I divide both sides by negative 2 to get the radical by itself, I'm going to create a fraction. And again, we don't want to do that. So I'll go down to step 2. Step 2 says raise both sides to a power equal to your index. It's a square root again, so we're going to square both sides. So we've got x minus 7 squared is equal to negative 2 square root of 4x plus 5 to the second power. Now x minus 7 squared means x minus 7 times x minus 7. And over on the right side, since everything inside your parentheses is multiplication, we can take everything to the second power. So I'll take negative 2 to the second power, and I'll take the square root to the second power. So I got negative 2 squared and square root of 4x plus 5 squared. Now back on the left side, FOIL this, multiply everything together. X times x is x squared. X times negative 7 is negative 7x. Negative 7 times x is negative 7x. Negative 7 times negative 7 is 49. On the right side, negative 2 squared is 4. And again, when the index matches the power, they cancel each other away, so we're left with 4x plus 5 inside of parentheses, because the 4 out in front has to be multiplied times everything inside. Combine together like terms. Negative 7x is negative 14x plus 49. And over on the right side, 4 times 4x is 16x. 4 times 5 is 20. Now we're at step 3. It says if you have more radicals, go back to step number 1. Well, we don't have any more radicals. So step 4, solve for x. We have a quadratic, x squared, so we want to get everything over one side, 0 on the other. So I'll take 16x plus 20 over. And I get x squared minus 14x minus 16x plus 49 minus 20 equals 0. Combine together like terms. Negative 14x, negative 16x is negative 30x. 49 minus 20 is 29. Yeah. Now this factor is using the PSD method. Factors as x minus 1 times x minus 29 equals 0. Zero factor property, you get 0 one side, you factor the other side, set each factor equal to 0. So I'll set x minus 1 equal to 0 and x minus 29 equal to 0. And we get x equals 1 and x equals 29. Maybe. Let's check them. If I put 1 up here, 5 times 1 is 5, minus 1 is 4, square root of 4 is 2. If I put 1 here, 4 times 1 is 4, plus 5 is 9, square root of 9 is 3. So I get 2 minus 3, which does give us negative 1. So that checks. Okay. 29. If I put 29 here, 4, 10, 145. I get 145 minus 1, which is 144, which square root of 144 is 12. Minus, and if I put 29 here, what do I get? 116 plus 5 is 121. I get square root of 121, which is 11. 12 minus 11 does not give us negative 1, so that doesn't check. Let me double check my math here real quick. 5, 4, 10. Okay. Where's my calculator? No calculator. How can that be? Okay. 29 times 5. 145 minus 144 is 12. Okay, that checks. It's 120. 16 plus 5, 121. Yeah, that's okay. So that one doesn't check. So our only answer is x equals 1. This is an example of showing where 1 doesn't work. Now I'm not going to actually work this problem. I never do in class. I just show the setup. So I go 5x plus 4 to the 1/2 power minus x plus 1 to the 1/2 power is equal to 1. Same instruction, solve. Well, remember, this is in rational exponent form, fractional power form. If I put this back into radical form, whatever number's in the denominator here goes in your slot, and then whatever power's up on top goes inside here. Well, we'd have 5x plus 4 to the first power, which is 5x plus 4. If I put 2 in here, index of 2, that's the square root, minus, and this would be the square root of x plus 1. Equals 1. Now, after we rewrite it in radical form, you notice it is exactly the same problem as this. Different numbers, but same idea. So when you run across problems that are have rational exponents on them like this, they're just radical equations. They're just written a little bit differently. And you do the same steps that we just did in the previous problems. Let's look at another one. Got a is equal to the square root of bc over 2x. And solving this for b. Now this one just extends our steps for solving formulas by adding a radical into them. So first let's focus on the radical. Remember our steps for solving a radical equation. Get a radical by itself. Well, this radical is by itself. There's nothing in front of it. There's nothing after it. Step 2, raise both sides to a power equal to the index. Well, this is a square root, so I'll square both sides. So that gives me a squared. And over here, the square root and the second power are going to cancel, and we got bc over 2x. Now, step 3, there is no more radicals, so we go to step 4. Step 4 says solve. Actually, I think it says solve for x, but in this case, we're solving for b. So we're going to go through our steps for solving a formula. If you remember those steps, our first step was get rid of parentheses, don't have any. Second step is get rid of fractions. We do have a fraction here, so we're going to multiply everything by the LCM of all our denominators. Now we only have one denominator, the 2x, so we're going to multiply both sides by 2x. So 2x times a squared is equal to 2x times bc over 2x. I'll put this in alphabetical order, not that it matters, but I got 2a squared x, and over on this side, the 2x here cancels the 2x here. And that leaves us BC. Step 3. Get everything with the variable we're solving for on one side, everything else on the other side. We're solving for b. Everything with a b is on the right side, and everything else is on the other side. Step 4. If the variable you're solving for is in 2 or more terms, factor it out. It's only in 1 term. Step 5. Divide both sides by what's in front of / back of the variable we're solving for. Solving for b, there's nothing in front of it, but there's c after it. So we're going to divide both sides by c. And when I do that, these c's cancel. And we got b is equal to 2a squared x over c. And that's our answer. I believe that was the last problem too. Yes, it was. So I'm going to go ahead and save this.